Hi all, happy Friday to everyone. Welcome to the next episode of YFTT, YugabyteDB Friday Tech Talks by engineers for engineers. I'm Kannan Muthukkaruppan, one of the co-founders at Yugabyte. It's my pleasure to welcome Amit Chauhan today of Yugabyte on today's episode. Amit, would be great if you could introduce yourself and then also the topic and jump right in. So welcome to YFTT.
Thanks, Kannan. Hello, folks. My name is Amit Chauhan. I'm solution architect at Yugabyte, and I've been with YugabyteDB around like 1.5 years. And before coming to Yugabyte, I have done a lot of software development for companies like Verizon, Charles Schwab, Shutterfly, etc. So today we are going to test drive YugabyteDB from the perspective of the application. So we have built one in-house application, very simple app, which I'm going to showcase. And let's dive right into it. So I have a few items. It's a pretty packed agenda. We'll try to squeeze everything in next half an hour. So first, I'm going to go with the very high-level architecture of Yugabyte, like the different layers of YugabyteDB. And then I'm going to talk a little bit about different deployment topologies, like with Yugabyte, like it's art of possible, like you can do it in so many different ways as per your need of your application. We'll walk through some of the popular ones, strategies, and then choose one of that topology to do our demo for. And I'm going to do two demos. First, I will take a cluster which is spun across 3 different regions across the United States, Ohio, Virginia, and Oregon. And then I'm going to fail the whole data center, the west side. And all this while my simulation workload simulations are running on the UI. So I will show you that there is like how RTO of 3 seconds, like within 3 seconds, the users get moved over to the newer nodes, and there is literally no impact to the application. And you will see it in all happening in the real time. And then as part of the second demo, what I will do is like I will scale this cluster from 3 nodes to 6 nodes, and this will be all like a rolling upgrade. And on the side by side, you will see that there is again zero downtime to the application. So once we are doing this demo, I'm going to go take you to the slides and show you how what is happening behind the scenes. Like what's the secret sauce of YugabyteDB, how it is handling these zone and region failures, and how what happens behind the scene when we are scaling out the cluster. Or same thing applies to if you are upgrading your database in a rolling fashion. So let's jump into it. Let's start with our architecture. So as you can see, it's we have 2 main components to the architecture. So on the top, you will notice there is a pluggable query layer, and all the client drivers, like they will be interacting from the app perspective. You will be interacting with this query layer, and there it's by design we have built it as a pluggable architecture. So currently we support 2 different APIs: YSQL API, which is Postgres compatible, and then we have YSQL API, which is based on SQL Cassandra query layer. And since our design is pluggable, like in future we might build some other APIs as well in here. So as per the demand of our customers. And at the bottom layer, this is where this is what we call .db. So it's a distributed transaction storage layer. And this guy is responsible for all the automatic sharding, load balancing, your distributed transaction, raft consensus between the nodes. So you can, it's truly share nothing architecture, and you will see the same structure like on each of the nodes. So it makes it very, very easy for us to scale out as per the need. And we'll talk more about it. We'll go into deep dive into some of these aspects as we go through this demo and presentation. And one key thing I want to mention here is that Yugabyte, literally, it's like you can deploy it anywhere. You can have it running on the cloud providers like AWS, GCP, or Azure, or like you can run it on-prem, or even as a mix of both. So we'll talk about one topology where you can have part of your cluster running on your on-premise data center and part on one of the cloud providers. So let's look at. I mentioned earlier that there are many ways like to lay out your topology, and we'll talk about these three ones. But you can literally do, because of our shared nothing architecture, and based on our architecture, like you can go and define any kind of topology which works for you. So first of all, like you can lay out if your need is that you need very low latency, but you still want to tolerate the failure of a whole data center or like a zone within a single region, you can lay it out your universe with single region multi-zone. So for example, in here, I have these 3 data centers, 3 zones, 1, 2, and 3. And your entire domain failure zone might fail, but it's still like as long as these other 2 availability zones are available, your application will be up and running. So there won't be any downtime to your app. So secondly, there is you can do single cloud multi-region. So for example, you can have your cluster in 3 different, spanning out the 3 different regions, and whole region data center goes down, your application will still will be up and running. And this we have encountered in the real time, like in real production use cases, also with some of our big customers. I will talk about it later on that too. And then last one which I want to mention is this multi-cloud, multi-region. So there are some customers who are kind of moving out from their on-prem solution to the cloud solution. So this kind of solution works very, very good for them. Like they can have the part of their universe running in cloud and part on their on-prem. So you can stretch it out the way you like, way you want. Of course, these one key thing which I would like to mention here is, as you're doing it, like network latency does come into play. So for example, like if you're running single region multi-zone, your latencies will be very, very low. But if you are like you are stretching your cluster across, say, different continents, you have some nodes running in Australia, some in Europe, and like part of the cluster is in United States, then these laws of physics come into play, and your latencies will be higher. So that is one consideration to keep in mind.
And maybe one comment I would add here is the deployment options you're seeing here are for a single Yugabyte cluster, which we are stretching here across zones or regions or clouds, depending upon your preference and application requirements. There is a thing we don't talk about on this slide, but you can also pair 2 Yugabyte clusters that are sitting in 2 different regions. Oh, you do? Okay, sorry.
No, it was in my appendix. Yeah, please go ahead.
Yeah, you can take 2 independent Yugabyte clusters that are each multi-zone, and they're sitting in 2 different regions, and you can pair them using a Yugabyte capability called X cluster replication, which is like essentially cluster to cluster asynchronous replication. But I think this is a little bit beyond the scope of this talk, so we'll go back to the flow. Yeah, thanks.
All right. So having said that, like we'll jump into our demo, and first, as I mentioned, like first we'll do a failover of entire data center and show the impact on the application. So this is one very, very smallish app which we have built in-house. And think of it as like similar to JMeter, but with a good UI. So you can go and it's pluggable architecture. You can go and plug in your queries, your workload, and then connect to a given database and run simulation. So you will let me go a little bit on that. So this is one live version which I have running right now. So what it does is like it will show you that your network topology, how your cluster is laid out. And as you are performing your simulation, it will show what's the latency, what is throughput. You can run like multiple workloads in parallel. So on the top, you will see those individual workloads running, and that at the bottom, you will see the aggregate, what's going on. And good thing with this app is that you don't need to do anything behind the scene. Like you can do it all from the UI itself. So you can click here, you can create the tables, you can see data, you can run your simulation, and whatever queries you have put in, and start from here. So before I do that, like I want to show you a little bit, like today's demo, I'm going to use YugabyteDB Managed. So we offer three solutions. Like we are 100% open source database, so you can download YugabyteDB from our GitHub repo, and you can run it without this particular control plane. And this one I'm showing you is cloudyugabyte.com. It's a managed service, so where we manage everything for you. So you just come in, you create your cluster, and then connect your app to it, and just run through it. So I'm going to include the link later bit towards the end of my slides, so you can bookmark it and give it a try. And then the third solution is Yugabyte Anywhere, which you can deploy it on your on-prem if you want to do it in your own VPC or on your cloud provider. So that is another option. Think of this as like as a control plane to make your day-to operations very, very easy. And I already have created these two different clusters in here. One is running like spun across 3 regions, and one is like a single region multi-zone. But I want to quickly show you that once you sign up on cloud, like how easy it is to go create a cluster. So you go in, you just give your name, you choose your provider. We have AWS GCP right now on IBM service, but Azure is coming very, very shortly in here. You choose your database version, and then if you want like a single region deployment or a multi-region deployment, so like it will. So in this case, I'm choosing multi-region. I go in and say I want this in Hong Kong, and I haven't created the VPC in Hong Kong. So let me get the one where I have the VPC. So you choose region 2, like you go in and choose, let's say, Ohio, and maybe the third one can be my Oregon, like the one I have created. And then you can specify the size you want, like how high you want to your nodes to be. Like you can start as low as like the 2 vCPUs, or I prefer like going with like 16, like if for production type workloads. Give your define and do a next, and then I can add my all my pairings to my app, and that's really about it. Like I download my credential, I create the cluster, boom, within 10 minutes, you will have your cluster up and running. And I'm not going to create one because I already have it. And everything, like if when this cluster is up and running in here, you can go and check what tables are there, like what is the performance. You can see, you can have like different multitude of things which you can monitor directly from here. So I'm just giving very, very high high level overview. So let's jump back to the app. Like, so this particular cluster which I was showing you, it spans across these 3 regions. You can see Oregon, Ohio, North Virginia. So I come to my application and I see the same network topology in here. And one thing which I want to do here is in this app, like I have, I encrypt and use the API keys. So like my account ID, project ID, cluster ID, and my access key, so that I'm plugging it in. So now you will see these names change to like the real node names. And you might have noticed that now my 3 new buttons have come in this application. So what this does is like behind the scene, it's calling these REST API calls. Same as like if I were to do some scaling, or like if I was going to edit an infrastructure, move things around, I will, it's the same REST API call which this managed UI is doing, and same thing I can do from my app itself. So that's the best part of like the way we have designed we are truly cloud native database. You can do it from multiple places. Like we have this Terraform provider to create whole infrastructure. You don't even need to hit this UI. Anyway, so coming back to this app, and very, very simple app. And I'm going to share the code base with you too. So you can, from the GitHub, you can download the release jar, or you can fork the repo and make your own simulation and run it against Yugabyte or any other database per se. So it, like from here, I can create the tables. I'm not going to do that. I'm just showing, and like I want to see some data, or if I want to say run some simulation. So I can have these read and write workflows. I can define my max thread. I can start the workload right from here. And once this starts, like it will start showing me what's going on with the application, what kind of throughput I'm seeing when I'm connecting. One thing I want to point out, my application is running in US East 1, which is Virginia region. So my app is somewhere here in this topology, and it's connecting to all these, to my cluster. These blue ones are regions, orange ones are availability zones where my cluster is laid out. And then these little computer type icon you see is my actual database node of the cluster.
And so, Amit, in this setup, one question: do you have your leaders? Which configuration option have you chosen? Have you spread your leaders across all regions, or in this particular case, you have picked one region?
So yeah, that's a very good question, Kannan. And so I have, in this particular demo scenario, I have kept my leaders spread across all these 3 regions. So if I go in here and let me quickly show this. So you will notice that all my read and write operations are spread equally among all these 3 nodes. So so you will see these things. And in ideal, like in production workload, my app will be distributed as well, like in or the other options like Yugabyte has a lot of flexibility. While creating my cluster or same cluster, I can, if I go and I can change my, I can do like a set as a preferred region for read and write. So suppose my application is in US East 1. In typical production scenario, I will set this as a preferred region, so that my latencies are much lower. But I wanted to show you like that how each node equally participates. That's why I kept my tablet leaders like across spread across these 3 different regions. Okay, and let's quickly. So these things like stopping the node and like it takes a little bit time to stop the node and bring back the node. So what I have done is I have this recorded and like in a small video. So we'll quickly go over it, and then we'll talk about the internals, what's going on. So let's jump right into it. So you will notice that I have this vivacious hair, which I was showing you. It is a region level fault tolerance. One of my regions can go down, zero impact to our application. So I have these 3 regions: North Virginia, Ohio, Oregon in here. And if I were to go to the notes tab, you will see the same thing, like that right now they are sitting here, not taking any traffic in here. I have loaded like 1 million rows or so. So it's not much data right now in here. So let's go back to the simulator, and I will move ahead a little bit in here. And so I will quickly bypass some of these things I have already covered, like what it does. Just want to show you, like if I load the data in here, so what happens. So right now I'm just seeding some new data to my table, and you will see that these are my transactions per second, my average latency across what I'm doing. And don't pay too much attention on this completed and time remaining. This is like number of invocations which I have given, that hey, run this 100,000 of times, like with these many threads. So it's like a workload which will stop after certain time. And going back to the cloud, like you will cloud and IBM UI, you will notice all my workload is very equally spread out among these three regions. So all my nodes are working equally hard in this case. So I will quickly fast forward through it, and my workload has completed. Now what I will do is, like, I will start some invocations. I want to keep it like 100 million or so that I want it to run for next half hour or so. You specify number of threads, like think of it as like parallel users or to simulate this. And I start my workload. Again, you will start seeing these transactions. And by the way, like I'm running one workload, but you can, in parallel, you can run like multiple of these guys in here. So you will, right now the read latency is around like 40 milliseconds or so. But remember, this is not like a preferred region setup. It's more of spread across the thing. So that's why you're seeing lower latencies in here. And again, read workload is very equally spread out. So let's these three nodes. And now I'm going to go and stop one node. So like everything is looking good and nice here. So I'm going to go and check this US West, which is Oregon. And I'm going to bring down the whole thing. So I make that REST API call directly from this application UI, and then I have. If I go back to Yugabyte managed in the activity, you will notice that I have issued this stock cluster node. So right now it typically takes 2 minutes, 2-3 minutes to go bring down the node. But you can already see that things are shifting from that particular node. You will see there is some changes to your latency graph, your throughput. And since the farther region from my app is going down here, so it is like my throughput has kind of increased, which sounds strange, but it's true, because like it shows you that like how network latency plays into the role. If my application was on the US West side, you would typically see your latencies go much higher, throughput fall down. So I will quickly fast forward through this, and you will notice that everything is like was very smooth. Like there was no application was 100% available. Now I have restarted this particular node in here, and you will see that it's in progress. So it will go in behind the scene, it will go and bring up that node. And if you were adding some new data, it will it will first it will change the tablet leadership there, and then it will also rebalance everything in here. We are going to go talk about with different diagrams also, like how this is handled in Yugabyte in a minute. So again, like you will notice that once this West thing came down, like you have this your latency again went up a little bit, and your throughput fell down to your original value. And here, if I refresh, I will see that my West region has come into play again, and it is back in action, taking the reads again from the application. So next, what we'll do is like there you will notice there is some jitteriness in the graphs, and the reason is like if I were adding some data, the things are being shifted to the new node also. So all that rebalancing is going behind the scene, and all this is all automatic. That's the best part. Like you don't have to intervene at all. Like so now I will take a pause in here, and I will go back to my presentation and show you like how this thing is achieved. So very basic concept, like starting with the distributing the data, right? Like I will cover some concepts in here and then build on that. So in order to achieve this scaling, or like what the most critical part is that you have this table, and you want like you need to distribute the data of a single table into multiple nodes. So very simple example here, I have this one region, 3 zones in this diagram, zone ABC, and I have one user table. So what Yugabyte will do is we'll take this table, we'll split into group of rows, and we'll spread it across 3 different failure zones. So I have this group of rows is referred as a tablet in Yugabyte. So you see here there are 6 tablets, and each tablet will have multiple rows for the given table. This sharding is all transparent to user. It's automated by default. It's a hash partition sharding, but you can we support range and list as well. Like you can opt for that as well. So now when I'm distributing the data, so this again, as I want to emphasize that this sharding happens automatically. Our load balancer makes sure that these rows groups are evenly distributed across these 3 nodes. So I broke it down as an example for 6 in 6 tablets, and now have it spread across these 3. And I'm keeping it simple, just showing 6, but for a given table, depending on the size, you will see that number of tablets will be much higher. Like they can be 10, 20, 30, or whatever. One key thing is like each row will belong uniquely to one tablet. So now in our demo, we were seeing that whole region failed. So let's see how Yugabyte handles these situations like region zone node failures. So if I had a single copy of data, you won't be able to survive the failure of the node, right? So the natural thing to do is like spread this tablet across multiple nodes. So in this example, I have a replication factor of 3. So I'm going to spread this tablet across these 3 nodes in this diagram. So for doing this, we are using this Raft consensus algorithm, and Raft will choose a tablet leader, and the remaining one will be the tablet, like the follower tablets. And this is important concept, like it will come into play in next few slides when I go and talk about.
Amit, one just in time check. We are at 10, but maybe we can go 10 minutes over. I just wanted to also share that there are 2 questions also. I was just deferring the questions till the end there, since they are on a slightly different topic. Yeah.
Okay. So I will quickly go through these slides, and I should be able to cover it in next 10 minutes. Sorry, folks, like I got a little excited and I covered a little more than I forgot about the time. So coming back here, like how replication happens in this 3-node cluster. So in this example, you will see that tablets are spread across these. So these solid lines you see, these is the tablet leader, this yellow guy. And then on the other two nodes, you will see these dotted line, which is like a follower node. And same like in zone C, you will have this thing like the yellow one. So, and on another zone, like this blue guy might be the tablet leader, and other zones will have the follower. So anytime like you are doing a read or so tablet leader is responsible for serving that read. So it will go and serve the read right away for you. But if you're doing like an update to certain record in that tablet, then the raft replication for updates will happen as soon as it gets the majority consensus. In this case, since there are replication of 3, so as soon as you get majority, which is from another node, like you will commit that record. And this is how we, in a way, we achieve like RPO of 0. And when we went and failed one node, right? Like so let's say I had this this diagram showing me 9 different nodes. These things are spread across, and node 4 got failed. So if you notice that there was one tablet leader in here, and there was this purple read one. So for read, if some data was being read from this purple one, that would never happen. It will always go through the leader, which is on this node 3. So read won't get impacted when this node goes down. For this yellow one, what RAF will do within 3 seconds, it's going to go shift the tablet leader. Like in this diagram, it's choosing node 2, yellow tablet as a leader. So within 3 seconds, like there will be slight impact for 3 seconds for this particular tablet, but new leader will get chosen, and your application will continue as desired. So one question which might come up, like what happens if this node never comes back? So by default, like we wait for it for 15 minutes and if the node has not come back for 15 minutes, what we'll do is like earlier for this particular tablet, we were kind of running with replication factor of 2, right? So we'll re-replicate based on our capacity on the other nodes in the zone. We'll shift this yellow tablets will re-replicate the data on another available node, so that you get your true availability replication factor of 3. And once this node comes back again, these things will shift back again to node 4. And again, like a very, very critical point, this is all automated for you. YugabyteDB will handle everything for you, as I was showing it on the application side as well, right? And these leaders and like Yugabyte does all the hard work behind the scene to keep these leaders evenly rebalanced. And whenever that failed node came back, like it will reshift. One thing which I want to mention here is that somebody might ask, why this 15 minutes? So this is configurable. Like there are many scenarios when your system administrator or DBA might be doing these rolling upgrades, right? So we don't shift the whole data per se, like for those kind of scenarios. So we wait 15 minutes. But if you want like a lower, it's all configurable. You can do that. So I will quickly go like this scaling thing. I will quickly go through it. It shouldn't take time. It will be 2-minute thing. So now what I want to do is like I want to scale my cluster, resize the cluster, and show you if there is any impact on the application. So I can do it from that API call, but what I want to do is go and edit the infrastructure in here from my YVM UI, choose the number of nodes, increase it to 2, and then just go click confirm and save. And that's it, guys. Like you can do it through CLI, you can do it through that API call, you can build it in the app, the way I have done it. And if you go and see this edit cluster functionality is going on. And the good thing about this control plane is like it will show you, it doesn't hide anything. It will show you step by step what's going on. Like it's going to provision 3 nodes. It is going to install Yugabyte software on that. And then it will start shifting the things around. So So very soon you will see that like each of these region will have extra node in here. And since we are adding more new nodes, right? So the important thing is like now my latency should go down, my throughput should increase, and you will very soon you will see when these nodes come in, my application will be like a linear type thing, right? So see, from 3K my throughput went to 6,000. So that's the power of Yugabyte. Like you need higher throughput. Like there are many customers of ours who are running their application like they're doing 600, 700,000 transactions per second. So you can, it's truly horizontally scaled, and there are no limitations like that. And just one more slide I have in here, which I want to quickly show that it's very same thing. Like if when I did this horizontal scaling, so I went in and I added new nodes. In this example, in demo, I went from 3 to 6, but if I were to go from 3 to 9, what it will do is like it will spread out, rebalance these tablets again, and it will even automatically split the tablets for you. Like if in this example, say I had very less tablets, it will automatically do that splitting for you. So everything is transparent to user. You don't need to do anything on that. So let's go back to, so this is one slide. Like if you want to go check out, sign up for our YugabyteDB cluster, you can go to cloud.yugabyte.com. It's all, there is a free option available, no credit card required. You go in and you sign up for it. This application which I was showing you, it's publicly available. So you can check out at this particular URL or with this QR code, and you can even write your own simulation based on your application need. And this is not just like if you want to compare different databases, like you want to see the performance or these features compared to Postgres or any other database, you can just plug in the driver and make these changes and try that out too. So let's Kannan, I think we can go through the questions also.
Wonderful. So firstly, thanks, Amit, for great overview and demo, both what happens behind the scenes, as well as a live demo of two cases that people often care about, like, like is a scale out operation online, or is a failure event, do things still stay online? And you showed both the demo as well as how this sort of the special sauce behind the scenes works. A few questions. So one of the questions I think from Rishikesh was, in highly indexed database applications, how are the indexes updated when upscaling or downscaling the number of nodes? Are the indexes copied or rebuilt on each node? Do you think there's a chance for index to go out of sync? So maybe I can take that question, Amit. Like, so fundamentally, Yugabyte is a ACID, a relational database. So indexes can't go out of sync. It is a strongly consistent system. And to the specific question of, is an index copied when new nodes are added, or is it rebuilt on each node? One way to think about it is, yes, even though to a user of the system, a table and an index looks like two different constructs, underneath the covers, they are actually both tables. For example, your main table might have a primary key of user ID, and it's organized on the user ID dimension. You may create an index on that table, maybe on the email address column. And that index is just another table underneath the covers, where its primary key is the email address and it's pointing to rows in the main table. So just like a main table, the index is also sharded. It's broken up into pieces. And when new nodes come, some of the shards of the tables as well as the indexes, they kind of get copied. And it's a very efficient process, because what you're now copying and rebalancing is on disk compressed structures and not rebuilding the index from scratch. So hopefully that answers that question. There's another question, maybe I'll relay it, and Amit, if you want to take that, go for it. So one of the questions is around um, why is there a performance difference between sort of single row inserts versus if the same insert had an index? Like once you have secondary indexes, why does the latency increase? I'm happy to take it too, but if you want to say a few words, go for it.
Go for it.
Okay.
Go for it, please.
So one of the essentially there's a fast path transaction protocol that we use if the update involves only a single shard. So when you have a simple, like say single row insert, and it doesn't have any index, then that protocol is just lighter weight. It only involves one wrapped group, and it's kind of like a one round trip protocol, and that's a much lower latency protocol. But the moment you want to update like two rows in the system atomically, or say a row and the index entry atomically, you have to go through the distributed transaction protocol, which is, think of it almost like a two-phase commit protocol. The first row or the main table entry may live on one wrapped group. The index entry may live on a different wrapped group. And it has to, you have to atomically commit across those two. So yes, the fixed cost, the latency is slightly higher once you involve multi-row or index operations. So in a truly shared nothing, scale out architecture, that is sort of a trade-off that one has to live with. So I hope that answers your question. I think you also had a follow-up question, which is, does the index live on the same shard as the respective row? No, it doesn't, because if you think about, like, for example, your main table having, say, user ID as the primary key, and suppose what you want to index is the email address column. Now, and this table may have 1 billion entries. So the index will also have 1 billion entries, and we shard the index on the email address dimension, that table, and the main table is sharded on the user ID dimension. So the shard criteria is just fundamentally different. But what you get in exchange, like if every shard maintained its local index, then and some systems do that, then fundamentally if you're looking up by email address this particular table, then you have to consult every shard to say, does your email address exist in the local index? So I think Apache Cassandra might have had that design where you keep indexes with every shard, but then your read performance suffers because you have to consult every shard's local index. Whereas in Yugabyte, it's truly a global index, and the shard is not co-located. So you pay a little bit of this penalty on the right side because you have to do a distributed transaction, but your read is super efficient. Whether you're reading through the primary key or through the index, you get a really like a point lookup by just having to go to the correct shard. Yeah.
These are very good questions, and I will highly encourage everybody to join us on our community channel on Slack. And any questions you have, like just ping me there. I'm there. Kannan is there. We'll be happy to connect with you and answer any follow-up questions you might have.
So with that, I'd like to bring this episode to a conclusion. Thank you everyone for joining. Have a great rest of the week and weekend. And I believe next week episode, we will be talking about an auto explain module that's available in Yugabyte's YSQL offering. This, to those familiar with Postgres, the auto explain module is a Postgres feature that works, in a similar manner for Yugabyte as well. And that and how it can help uncover slow performing queries or unoptimized queries in your system. So see you all next week, and Amit, over to you for closing comments also.
Thank you so much, Kannan, and thank you everybody for attending today's session. I enjoyed presenting it, and I hope you got something out of it too. So do connect with us on Slack and any follow-up questions. Thank you.
Thanks all.